So today let's explore an interesting piece of laboratory equipment, this milliohmmeter donated by a viewer. So big thanks for the donation, and especially for the ordeal he had to go through to ship this, because this bloody machine weighs about 30 kilograms, and it's about 46 by 21 by 29 centimeters, so it's an absolute anvil. And it's all to basically measure the resistance of something in milliohms. And it comes with some measuring cables here, some high current, super thick cables, a pair of cables coming from it, bloody thick, and this mains cable with a mains plug and this plug going into the back of it. It seems to have a display made of Nixies, some polarity indicator and 4 digits, and some indicators out of range, doesn't comply with the norm, unfinished measurement, fuse A, fuse B and mains. I guess this indicates a blown fuse. This is the mains power indicator, and to control it you have the mains switch here, some range switch with 6 positions here from 25 amps to 80 amps. Maybe this knob used to have some cover on it, I guess. And here's a big knob, and this actually chooses the measuring current. And I guess this one indicates how to adjust it. There are arrows. I guess when this lights up you should go to the right, and when this one lights up you should go to the left until you get it to the center. It's basically a bar graph indicator with 7 LEDs, and of course to measure very low resistances I guess it has to use a Kelvin connection, basically 2 terminals to connect the high current for the measurement and another 2 terminals to sense the voltage drop. This one has a green cover, this one used to have a red cover but it got crushed under it in the shipping I guess, and this seems to be a little bit of a botch. Not sure this is original from a manufacturer, not even sure did they make more of these or is it something custom, but I can't imagine this produced in bigger quantities anyway. Now let's take a look at the back panel, not that much to see here. This plug goes in here, there are 2 fuses with screwable covers, they seem fine. And this one says fast 6.3 amps, and it actually is fast 6.3 amps, something you don't see very often, and this one is 0.1 amp slow, and it actually really is 0.1 amp slow. I almost can't believe it. And it says 1250 bloody volt amps, basically to measure the resistance of something. This is bloody amazing. Current milliohmmeter, made in a machine and tractor station, Opava City in Czechoslovakia, probably in the 80s. And some series number looks like 249, and they probably made just a couple hundred of these. And of course at this point everybody's screaming power it, so let's power it and let's see. Let's turn the mains switch on. And the display comes on, and the brightness went up sort of gradually. It says out of range, not compliant here. And these interesting nice flashing lights in pairs. Here it says it has mains voltage and not indicating any blown fuse. What happens if I turn this? And by turning it all the way down, I activated this LED. Do I have to connect these? Does it have any effect? Of course it's a bit tricky idea to touch it, but anyway. These have to be connected to it. It should actually read 0 resistance or a very low resistance. Well, a short circuit is still not a 0 resistance for this, because it's always some resistance of the conductors. Does not do anything. It just shows a different random number every time I power it. I guess there should be some bloody current going through these cables, shouldn't it? Is it AC or DC? Nothing. I think there's time to open it and to see what the hell is going on in it, and how a resistance meter can weigh about 30 odd kilograms. Each side of it has a handle on it to give you some chance of transporting it, and 2 screws here, so let's unscrew it. Of course, slotted screws. I took 4 screws out of it and the cover should come off, and here are the internals. You can see a panel meter module here with its own supply transformer. This is basically a module of a panel meter which is meant to be built into machines. And this module says 220 volts, 50 Hz, 10 volt amps, some type number 89. Is it made that late? But it's of course possible. N1T 240 type panel meter, and typically it has a plastic cover all over it, but this one seems to be somehow crudely cut out, maybe to prevent it from overheating in a double enclosure. Here you can see the internals of the meter a little bit. There is some other transformer, small transformer for the internals. Well, I call it a small transformer because I saw this one. There is some, I guess, current sensing shunt on very thick wires. This is the terminal block for the primary, I guess. This is, I guess, the secondary producing the super high current. This is sensing it. And again, this current sensing shunt has a Kelvin connection with two wires basically separately sensing the voltage drop and other two wires bringing the current into it. And this basically avoids measuring the resistance of the screw terminals. And here is some board associated with this LED indicator here. I guess 7 LEDs and 7 maybe op-amps or comparators. Flipping the LEDs here, plus some transistors, some chip. I guess it's some very primitive logic. 7437 from 7400 TTL logic. This panel meter connected using this connector. A lot of cables here on this side. This is for the range switch. Not sure what's here, but you can see a bloody number of multi-turn potentiometers. I have never seen that many multi-turn potentiometers in one device. That's interesting. And this is also on a connector. Here the transformer has the super thick secondary going from it. Here the cables go out. Here's a double switch. Basically two stacked switches to switch the live and neutral of mains using this. Of course, some board with LEDs here for indication. Most of them are red, one green for the mains voltage indication. And on this side, well, this knob actually seems to go to a variac. And this is an interesting mechanism. Here's the variac with the sliding contact sliding on a winding to basically set an AC voltage from 0 to full mains voltage or even higher. It says 220 volts here, that's the input of mains, 125 volt input not used, 0, not sure what's this, the slider I guess, and 250 volt tap. This is the top of the winding. And as you turn it, you also turn this. When you basically turn it all the way down, this lever presses this switch. This is actually what initiates the measurement. This is some sort of an interlock that you have to turn it all the way down to initiate the measurement, so you always start at the minimum. There is some speaker which looks like from a telephone, and the fuses, the mains in here. And here's the bottom of it. The screws of the big transformer, which is absolutely huge and is probably most of the weight of it. But also the variac and a couple smaller transformers, and this entire thing is a big heavy metal box. At the bottom here you can see the core of the huge transformer, which basically goes all the way into here, and some other components. Another small transformer here. This is mostly passive things, capacitors, resistors. Another board here with some transistors. This is bloody complex. Here's the slider of the variac sliding on the winding, and the slider has to have some heat sink, I guess. But why does it not produce any current here? I guess this transformer has a primary which has to go into the variac, and the variac is connected to the mains, probably not straight through this switch, but through some contactor. Where the contactor could be? There's a big metal box in it here, measuring the voltage of the variac inlet. Nothing. And the live and neutral of the terminal block of the big transformer, again no voltage. And also the two measuring cables showing no voltage. It seems like the control circuitry of it and the panel meter are working, but the power section not. If I connect this pair to this pair, still nothing. This indicator stuck at the first LED. But in either case it seems the measuring current is actually AC, not DC. It basically just passes a high AC current through a low resistance that you're measuring and senses the voltage drop on it using the other two terminals, and based on the ratio of the current and the voltage drop, it measures the resistance. Well, I started taking a closer look at it, and it seems there is a lot of connectors for the internal connections. Another connector here, and in the back of it, it looks like one connector actually came off. And this plate was probably originally meant to keep them in place. This actually looks like the problem. I put the connector back into its place, and now let's test it. And this is dodgy. I should probably screw it on some piece of metal. Turning on. Yes, it's working. No, it probably took the measurement, 0.6 milliohms. Another measurement, turning it up, centering it on the red for long enough, and it measures this, I guess. What if it's open a circuit? And then I of course can't get it to the... Let's try to use this saw blade as a low resistance resistor for the test. Dodgy enough, and turning it up. It still shows a 0.6 milliohms. What if I use a different range here? I'll waste this reading, but now it no longer indicates out of range or some other error. And of course this is getting a bit hot during the measurement, or quite hot if I turn it too much up, and I don't hear any contactor clicking. I guess there is a triac or a thyristor to switch it maybe. And when you manage to get the current to the center here and keep it there for long enough, it basically takes a measurement and then it deactivates the transformer. But not sure it's working properly because it never reads anything else than this. I tried to measure the resistance of multiple meters of a cable and still showing just this. And of course this video is taking bloody long to finish because I had to take a break. I caught the creature again and I didn't even have a voice. I accidentally found this cover for this one in the box at the bottom. And now of course let's try to fix it with my brain fog for your entertainment, and not that I have any use for this machine, but at least for education. It's still not measuring. I tried to reverse the leads. Of course polarity doesn't matter in AC, but the phase might matter. But in either case, it's still reading very low. 0.6 as always. And measuring the variac, it can go up to 260 volts. The open circuit voltage of the electrodes is 13.7 volts at this, and at 230 volts the voltage at the output on the secondary 12.3 volts. So it's basically a 12 volt transformer, which could be useful separately. 12 volts and maybe something like a kilovolt amp of a transformer. Of course the variac, which I guess is about 5 amps, is also very tempting to just take it out of it and use it separately. On the back it says 1250 volt amps, and for 250 volts it would be 5 amps. And besides the transformer and the variac, even the panel meter could be used separately, I guess. I'm trying to disconnect and reconnect various connectors in it and it still won't work. Might actually be damaged from the shipping, I guess. Maybe it actually worked before it was shipped. Take a look at this screw, how it's bent. This one actually, the nut came off and stayed under this plate before it was dropped, so it's not bent here, but this one is quite bent. Is the screw of this transformer. Nice. Let's explore it further. I guess the meter is just on one screw here. Let's unscrew it. And then this entire module comes out with the nixies and the screws. 4 screws of something else under it. Let's unscrew this. Unscrewing the 4 screws, and they're using bigger nuts as washers or spacers. You have to take this off. Now this thing should fall out. And that's it. Some power transistor and a 7805 regulator of 5 volts. Small transistors, some capacitors, It looks like a power supply. There is actually more boards, 3 boards stacked in it. Here's the switch for the ranges and a lot of other circuitry here. Let's try to take the boards out of the housing. There are screws again and bigger nuts as washers, spacers. I have to say this low volume or custom communist production really doesn't look very far from a DIY construction, does it? Here are the boards, some spacers made of absolutely whatever was available. These insulation things on the edges of the boards. This looks interesting. I guess this is the power supply of this section. The next board is this thing. Nothing is straight here. Here's the amazing row of 12 multi-turn potentiometers and a lot of other resistors. And the range switch here. Not sure what's this. Some capacitors soldered onto this. And then this soldered into the board. Let's pull this one out. And after this analog board, we can see the last one, which is digital, a lot of chips and not much else. And that's it. And this entire board is all 7400 logic, 7493 4-bit or base 16 counters. You put the boards back, maybe there is just a poor contact. It seems like a center tapped transformer and 2 diodes rectification here in the power supply. Is it? There is some voltage, 17 volts. And the transformer with the bent screws seems to be still working. Some capacitors. This is actually the same voltage from the diodes. And this should be, one of these should be from the 7805. Why it's negative? Well, I'm measuring the heatsink of the transistor, not 7805. Of course, I was probing my negative probe into 5 volts, so it was basically subtracting 5 volts from whatever I was measuring. Now it's right. 22 volts is the rectified unsmooth voltage from the transformer. There should be some 5 volts here from the 7805 and some other voltage from the power supply. There is MAA 723 regulator controlling the transistor, the power transistor, and I guess 12 volts is generated using this thing. I tried to take one more measurement and it's still showing this, 0.6 as always. So it wasn't a poor contact in the connectors, it has to be something else. And here's the board on the back with all the connectors. And of course in the cables, one of these is from the current sensing shunt and one is from the voltage sensing terminals. And of course I'm not sure how far I want to go fixing this bloody 30 kilogram crazily complex resistance meter that I have absolutely no use for. We haven't seen yet this side of it and the metal box in it. I took the boards on the right side of it out and this was just screwed to the bottom using 2 screws, and there is basically some tiny auxiliary power supply transformer, I guess. Some bridge rectification, some capacitors. And that's another power supply here. And then I can see a big bridge rectifier out of 4 metal diodes and a thyristor KT708. I looked it up, it's 700 volts, 15 amps. It's a thyristor, but I guess in combination with the 4 diodes, it works as a triac, switching AC voltage to the transformer primary. And the other side has some beeper, maybe some alarm for overload or something. Some transistors. Whatever this is. It's sort of rubbery. Is it some opto-isolation? There is a huge isolation gap and I don't know. And a lot of transistors here and a capacitor. Now of course the question is, what's in this metal box? It's out, one screw was missing in it. And removing the cover end, it seems like some interference filter with inductors and capacitors and a schematic in it. Nice. Seems like a typical interference filter, double inductor in it. Some terminals, connections, a capacitor and some other double inductor. It says 100 nano plus twice 2.5 nano. Capacitors 250 volts, 10 amps. An interference filter with a schematic included and in a solid metal box. Imagine that. I can't imagine something like this in modern appliances. I put the right side of it back together. I don't think there is anything wrong here. This double board probably does the primary winding switching. This is basically monitoring the current and giving you the directions how to control the variac. Nothing wrong with this one as well. This is an analog to digital converter, converting some voltage like up to 200-300 millivolts to a digital reading. I guess the problem has to be somewhere here. And besides the positive 12 volt rail, the power supply also has a negative 12 volt rail. As you can see, it's working. And the plus and minus 12 volts is used for the op-amps. And the 5 volts for the logic. I guess nothing wrong with this board of the power supply. The problem has to be in this board, I guess. This one contains 3 op-amps. 2 op-amps here. MAA 725 and one more on this additional board. And I'm thinking how this was even working, because typically a resistance meter contains a constant current source and measures the resistance based on the voltage drop of the resistance at this current. But here the current isn't really constant. You can never really manually set the current accurately enough using the variac and this crude indicator to take a precise digital reading. So I guess instead of just measuring the voltage drop of the resistance you're measuring, it has to be measuring the ratio of the current through it, using this current sensing shunt and the voltage on the resistance you're measuring. The resistance basically is the voltage divided by the current. And if it's the case, it actually requires an analog division, which is not an easy thing to do, especially not with a high accuracy. Does this do some analog division? And then of course there is this 10-chip logic circuitry. I'm not really sure what this does. This is quite a bloody complex thing, and I don't think there is any schematic for it. I guess the problem has to be on one of these boards, and because the chips on this one are socketed, let's just replace all the chips in it and let's see what happens. Why not just go about it the lazy way, especially when you're demotivated from fixing it? Now all the chips in it are changed. I put it back together and it still keeps showing 0.6. Of course, when you have a schematic and you're familiar with the machine, you can shrink the surge down to a small area based on the symptoms and then look for the bad component in just a small area. But not being familiar with this one and having no schematic, I have to search more blindly in a larger area and use a more general approach like measuring all the resistors, capacitors, diodes. Not knowing how exactly this one operates, testing also can't shrink the surge to a smaller area, so I'm measuring various capacitors, resistors and so on. Let's measure some capacitors, and of course I measured all of them already and they're charging, no short. I basically test all capacitors for shorts and all electrolytic capacitors for high ESR. Capacitors typically can be tested for a short and ESR in a board, but the capacitance can't be measured in a board. I measured some diodes, they're good. I measured all the resistors basically in it, and they're good. Resistors typically can be measured in circuit, and if there is something connected to them parallel, it can skew the resistance measurement down, not up. If you're measuring more resistance than the resistor says on it, it's probably bad. I've tested all the capacitors, ceramic, film, electrolytic, all the resistors, the potentiometers. The resistance measured from the slider to each end of it has to always be the same or lower than the marking of the potentiometer, otherwise it indicates that the slider is not making contact or the resistive trace is broken. There is also a circuit with multiple resistors built into it, and it also seems good. Basically absolutely no faulty component here. I was almost blindly replacing the op-amps because they can't easily be tested. Of course, having the boards stacked in it, you can't really probe into it when it's running. I was almost blindly replacing the op-amps, but then I had an idea to measure the switch. The switch has 6 positions, and in each position it connects 2 pairs of pins. In the first position, for example, it connects these 2, and in the 6th position it connects these 2 pairs. I was checking it using a continuity test, and it turned out that these are not working. The outer ones are making a connection, but not the inner ones. I guess this is from the shipping. It got dropped, and because the boards are in a heavy metal box, the box moved and it basically bent or pulled or pushed this shaft going through the front panel and damaged the switch. Trying to take a closer look at it, I guess some of the pins are broken here. It's also at an angle. This is making a contact. This is not. I just jumpered it permanently for the 80 amp range and let's try to test it. I've made a Kelvin connection to my saw blade again and... 7.7 milliohms. Of course, as it's getting hotter, the resistance goes up a bit. And measuring certain length of a cable. About 100 milliohms. And testing about 1/3 of the length. Showing 33, which definitely makes sense. I was measuring 3 wires in this cable in a series and then just 1. So that's this machine actually working. And of course you can take a very similar measurement using just a bench power supply and a voltmeter. Setting the bench power supply to a 1 amp current limit. And the voltmeter reads 0.03 volts or 30 millivolts, which at 1 amp means 30 milliohms. A combination of a bench power supply and a voltmeter can also measure very low resistances, except that it measures at a lower current, so it doesn't heat up the cable or whatever you're measuring, so it can't simulate the temperature drift at a high current. Trying a modern multimeter, again in a Kelvin connection, and it gives a very similar reading. A 0.1 milliohm resolution basically, the same as this machine. And the bench power supply is 2 amps, about double the reading. I put the jumper here to test it at 25 amps. Now putting all 5 wires in a series. And it measures 161.9 milliohms. And the meter seems to have 2000 counts. And the reading actually changes based on how I turn this variac, so I guess there is no division. It just tells you how to set the variac and measures the resistance based on the voltage drop. Analog division really isn't an easy thing to do. I don't see how this one would do it. It really just tells you how to set the variac using this scale, which is sort of logarithmic, much more sensitive in the center. So you can set it with some sort of precision. You basically set the right current and this just measures the voltage drop on the measured resistance. And the machine is now working, and then this switch is permanently set to 25 amps. It's usable, but I don't have much use for it. And I guess this variac is made by some German company, which keeps making the same variacs to this very day. Just a different color of the plastic. No change since the 80s, but when you think about it, how could you possibly improve a variac anyway? And of course it never took me so long to finish a video, but if you like my videos, please consider supporting my channel on a Patreon, using the thanks button or subscribing. And big thanks to all of you who already support me. This channel wouldn't be possible without you.